Okay, now before we do these next ones, there's something important I have to kind of teach you for it to make sense. I want you to look here. Let's say the money I made from making things and selling them is $600, but I had to spend $200 out of my own pocket to make the supplies. The profit, the money I actually made, is $400. Okay? Because I have to take that minus what I've spent out of my own pocket to find out how much I really came out ahead. Now here, I want to put 600. Now let's say here I made $1,000, but I had to spend 600 out of my own pocket just to make the supplies. That minus that's 400. So as you can see, the profits are equal, but the amount I made is higher here, but here I also had to spend more money to make the supplies, okay? So that's kind of how profit works. You can be making different amounts of money, but it's all about kind of what you spent too. So let's take a look at this. These are a little more complicated than the other one. By the way, see that 4 right there? Put a negative in front of it. The profit P in millions of dollars for a manufacturer of MP3 players can be modeled by P equals negative 4x to the third plus 12x to the second plus 16x. P represents the profit in millions of dollars, and X represents the number of MP3 players produced in millions. Currently, the company produces 3 million MP3 players and makes a profit of $48 million. But what lesser number of MP3 players could they produce and make that same profit? And we saw over here that, yeah, you can produce less. You won't make as much, but you also spent less with your own money producing the thing. Okay, so like on those other ones, we need to write the equation. P equals negative 4x to the third plus 12x to the second plus 16x. So we need to go off this side and tell what these variables represent. P represents the profit, and that's in millions. So I'm going to put profit. And actually, why don't you just put dollars, because that's what profit really means. Profit in millions. And that's important, the fact that it's in millions in the equation. And X represents the MP3 players produced. So MP3, and put millions there. Okay, now what values do they give me in the problem? They tell me this fact that the company produced 3 million MP3 players and makes a profit of $48 million. Well, those are actually one of each of these, okay? So I've got 3 million MP3. I want to write that down. And MP3 would be an X value. And while that's happening, they make $48 million. So those two kind of go together. So 48 million. And that's a profit. So that'd be P. Okay. Now here's a nice thing. Since they're in millions, we can just use 3 for X. And since the profit's also millions, we can use 48 for P. Now, I want you to plug those in for the appropriate letter, okay? So P, we're going to put the 48 in, and then we're going to put the 3 in for all these X's, okay? And what I'm doing is I'm verifying that this, if I put 3 in for X, I need to verify that that actually equals 48, okay? So I'm going to roll that into my calculator. And I want to verify that that's actually going to give me a profit of $48 million like these guys told me that it would. Because I know if I can prove it for myself, I'm good. Yep, it does, okay? Now, here's what you want to do now. You want to leave 48 because we want to leave the profit the way it is. I'm happy with making 48 million. But I want to find maybe a different X that can give me 48. So negative 4X. This goes back, the 3's go back to being X's. Okay, so as you look at that, how many X values do you have? You got 3. And we already know what one of them is because I just had it in for my X a second ago and it was 3. Okay. So now I clear the side of the equation. And then since I have my first answer, I am going to synthetically divide by 3. So I've got negative 4, positive 12, positive 16, and negative 48. So you drop him, negative 4. Okay, and then 0, 16, and then 48. And that gives me 0. Okay, so now my new equation is negative 4x to the second. We wouldn't have x because there's a 0. It would be just plus 16 equals 0. Okay, now we can solve this using like terms. I don't need to factor because all I have is the x to the second. I can just focus on getting that by itself. Okay, factoring would be totally pointless and a waste of time here because I can easily just solve it by isolating the x variable. So I square root. 4 is a perfect square, so it's plus or minus 2. So 2 and negative 2. Now the negative 2 is a non-legit answer. So these are my two answers. These are the two numbers of MP3 players I can sell to make that $48 million profit. Okay, so they're in millions, so put million and million. Okay, now let's keep on rolling. Obviously, you're not going to really do very well if that's all we do. Okay. The profit P in millions of dollars for a shoe manufacturer can be modeled by the equation P equals negative 21x cubed plus 0x plus 46x. X is a number of shoes produced in millions. The company is now producing 1 million shoes and they're making a profit of $25 million. But they'd like to cut back on production. What lesser number of shoes would yield the same profit? So again, whenever they start giving us equations, they give it to me, 0x. I need to write it down and then know what the variables represent. Okay, so again, P's profit, so just put money, and it's in millions. Okay, and then the X is whatever we're producing, in this case, shoes. And that's also in millions, it says. And you're going to notice I make typing mistakes a lot. Okay, so what numbers do they have available for us? Well, we got 1 million shoes, so 1 million shoes. And what else they got for us? $25 million. Okay, the 1 million shoes is an X value, and the 25 million is a P value. Okay, now put those into the equation to verify that 1 million shoes will actually give me a $25 profit. So I'm going to put 25, then I'm going to put 1s in for all my X's. So 25. And yes, I want that 0 there. You're going to see why later on. Okay, now plug that in. Just make sure that that equals 25 equals what it's supposed to. You're verifying that that's one solution because they told me it was, but I want to make sure. Yep, 25. So I want to keep that at 25, but now I want those 1s to change back to X because I want to find if there's a different number of production for the shoes that I can actually make. Okay, so the equation's got 3 viable solutions, and we already know what one of them is. I just had it in a minute ago with these 1s. So 1 is your first answer. Okay, get that 25 out of there and just put it. It's important you do that because you need one side of the equation clear to run your synthetic division. So you're going to divide by 1. Negative 21, 0. That's why I put the 0 there so people wouldn't. And that's 0 to the second. Sorry, I didn't write that right. It's not really going to affect the problem much. 46, negative 25. So we drop him. Negative 21 times 1 is negative 21. That's 25, and got it. So now that goes from an x to the third to negative 21x, negative 21x squared minus 21x plus 25 equals 0. Okay, so there's 3 terms, so I'm going to run my GCF and then my t-test. But I'm going to show you a little thing on the t. GCF, well, you at least have a negative here because you have a negative front, and you can't divide by x, and you can't really divide 21 and 25 by anything, so it's just going to be -1. So that gives you 25x squared plus 21x minus 25. 21. No, that's 21. Sorry, 21. So ABC. Now 21 times negative 25. If you get a T-chart number that's higher than 100 when you take A times C, I would just use the quadratic formula, no questions asked, because I don't really want to find factors of 525. Okay, so opposite of B be negative 21 plus or minus the square root B squared minus 3 straight parentheses. And then we're going to have 2 times 21, which is 42. Okay, so B is 21. And then 4. A is 21. C is negative 25. Okay. All right, so you got negative 21 plus or minus, and then 42. Okay, if you don't, I'm going to plug this into the calculator. If your calculator doesn't help you like that, you know what you need to do. So I've got second square root, double it, 21 to the second minus 4, 21, and negative 25. Okay, and that gives me 50.4. And then I just continue on. I take negative 21 plus 50.4 equals, divide that by 42, you get 0.7. Negative 21 minus 50.4, divide by 42, and negative 1.7. Okay, the negative's non-viable, so those are your two solutions, okay? And they're in millions, so you could produce 1 million shoes to make the 25 million profit, or you could produce 700,000 shoes, which is what 0.7 million actually is. Okay, let's keep this rolling here. One of the costs to print novels can be modeled by the equation C equals x to the power of 3 minus 10x squared plus 28x. X is a number of novels produced in thousands. The company is going to print 5,000 novels at a cost of $15,000. Where their numbers of novels produce the same amount. So write your equation down, because they pretty much just give it to me. And then write what the C and the X actually represent. So it says C is the... I didn't tell you what C is, my fault. C is the cost, that's your money amount. And that's in thousands. Okay, X is in novels that are produced, and that's in thousands. Okay, so what do they give me? They give me 5,000 novels. And they say that 5,000 novels will make me $15,000. Okay, now the novels is an X value, and then the 15,000 is a C value. So put those in to make sure they will match up. So put 15 in for C, and then put 5 in for all your X variables. So 15 equals 5 to the third minus 10 times 5 to the second plus 28 times 5. Okay, so plug that in, make sure it equals 15. It should. Unless they told me a lie in the problem. Yep, 15. Okay, so I still want this 15 to remain the way it is, but I want these 5s to change back into X's, because I need to find other X's that will equal 15. I already know 5 does from them telling me that. Okay, so there's 3 solutions, and we know our first one that gives me 15 is 5. So I need to move the 15 over, And then I can synthetically divide by 5. So I got 1, negative 10, 28, and negative 15. So 1 times 5 is 5. That's going to be negative 5 times 5 is negative 25. And then 15. Okay? Okay, so now our new equation is 1x to the second minus 5x plus 3 equals 0. Okay, there's not, it would be GCF and then the T table. GCF, we don't have one. And there's also no way to find two factors of positive 3 that give a sum of 5, so we go to the sum. So opposite of b, so it'd be 5 plus or minus the square root. And then 2 times 1 is 2. So b, negative 5, and then 4, 1, and 3. Okay? So we got 5 plus or minus something over 2. We got to figure out what's in that square root. Okay, so 5 plus 3.6 is 8.6. You divide that by 2, you're going to get 4.3. 5 minus 3.6 is 1.4, and you divide that by 2, you get 0.7. Okay, so all those are actually viable solutions to the problem. They're in thousands, so that would be, just put a thousands. And all those are viable. Okay, those are all numbers of novels you can produce to make the $15,000 profit from the equation. Okay. Okay, next one. The profit P in millions of dollars for a t-shirt manufacturer can be modeled by P equals negative 1x to the third plus 4x to the second plus 1x. X is a number of t-shirts produced in millions. Currently, the company produces 4 million t-shirts and they make a profit of $4 million. What lesser number of t-shirts could the company produce to make the same profit? So again, equation P equals negative 1x to the third plus 4x to the second plus 1x. Okay, so P and X. Again, P is your money and profit, and it says that's in millions. And then what we're selling this time is t-shirts, and that's in millions. Okay, so they give me two values, 4 million t-shirts, 4 mil t-shirts. And they say that that makes a profit of $4 million. Okay? So, well, they're both, it doesn't really matter, I guess, because they're both 4s, but this one would be your X, and this one would be your P. Okay, so we're going to put 4 in, then we're going to put 4 in for all the X's. So 4 equals negative 1, and then 4 to the third plus 4, and then 4 squared plus 1, and then 4. Okay, I just want to verify that that equation works. Yep, okay. Now, I want this $4 million profit to stay, but I want those 4 million t-shirts to change back to X because I need to find what other X is that we can do. So there's 3 answers, and I already know that one of them is 4. So find the other 2, you get that out of there. You got to clear that number from that side because you need 0 before you synthetically divide. So you're going to divide by 4. Negative 1, 4, 1, and negative 4. So drop him. 0, 1, 0. Okay, so we got negative 1x to the second. We wouldn't have x. We just have plus 1 equals 0. And now I can just use like terms. I don't need to do factoring procedures here. Divide by negative 1. And x squared equals 1. And the square root of 1 is plus or minus 1. Okay, so 1 and negative 1. That's not viable. The other 2 are. So producing 4 million and 1 million t-shirts gives me a profit of $4 million. Okay, next. The profit P in millions of dollars of a manufacturer of iPods can be... I actually already did this problem. Okay, so don't do it again. Okay, and the last one I'm going to go over is... A video game company's profit can be modeled by the equation P equals x to the third minus 12x squared plus 35x. P represents the profit in millions of dollars. X represents the number of video games produced in thousands. Currently, the company is producing 3,000 video games and making a profit of $24 million. What lesser number of video games will yield the same profit? So P equals x third minus 12x squared plus 35x. Okay, got to know what the variables stand for. Okay, so P is your profit, and that's in millions. And then X is a number of video games. That's in thousands. So video games, and that's in thousands. Okay, so what do they give me? Though they give me 3,000 video games. They also give me $24 million. Now, video games is an X value, and then the money's a P value. Now, since it says that's in thousands, I'm going to just be using 3. And since it says that's in millions, I cross out the zeros. That means I can just use 24. So I want to verify that if I put 24 in for P, then putting 3 in for X will actually equal 24. Okay, so 3 to the third minus 12, and then 3 to the second, plus 35, and then 3. Yes, it does, okay? So I want that 24 to remain that profit, but I want to switch these back to X's to see what else I can do. Okay, so there's 3 solutions for the X variable to equal 24. We already know one of them's 3. Okay, move that 24 over. You got to remember to do that. And now we can synthetically divide by 3 because we got 1, negative 12, 35, and negative 24. So drop him. It's negative 9. It's 8. That's 0. Okay, so now what do we really have? We got 1x to the second minus 9x plus 8 equals 0. And then we run the GCF and the T because I can't just use like terms. No GCF. Positive 8, sum of 9. Actually, we could find that because it's 1 times 8. A is clearly equal to 1. So I don't need to go to the sum. It's factorable. So I got minus 9, so you got minus 8, and sum means they're both minus. So x minus 1 equals 0. X minus 8 equals 0. Plus 1, I get 1. Plus 8, I get 8. And those are 3 viable solutions. Okay. So, and remember the X is in thousands, so that would be thousands, thousand, thousand. Any production of any one of those gives you a profit of 24,000. Okay, now the next one, that's a negative 5x to the third plus 6x squared plus 15x. 14 and 2 would be your 2 numbers.